Before we talk about step 3 and calculating our test statistic, which we'll see you're not going to actually have to do. Woohoo! We have to talk about this whole idea of expected count, because this is really the basis of chi-square analysis and how we determine whether or not we are going to reject the null or fail to reject the null. So expected counts. This is really the expected probability of the two independent events happening at the same time. And so we're talking about these two independent events. This is simply the IV and your DV. If they are happening at the same time, what's the probability of us seeing certain number of people within each of those cells? So if the null hypothesis is true, that there is no difference between the groups on your IV, on your DV. In this case, there are no differences between teachers, salespeople, and farmers on political affiliation. Then A and B are independent events, that no matter what, there is no influence, there is no relationship between occupation and political affiliation. These two events are completely independent of each other. That it doesn't matter what your occupation is. It's not going to matter on what your political affiliation is, and vice versa. No matter what your political affiliation is, it's not going to matter upon what your occupation is. These two events are completely independent of each other. So if we assume that the null hypothesis is true, then we can expect to see certain amount of people that are Democratic teachers, that are Republican salespeople, that are independent farmers. And so this equation of our expected counts is simply n of A, so the number of people that we have for one event happening, times the number of people that you have for event B happening, divided by your total sample size. So let's start with 3 examples here. Let's work through the first one together. So a Democratic teacher. How many people would we expect within the sample of 100 people to be Democratic teachers if occupation and political affiliation are completely independent events, that there's no relationship between them? Well, how many Democrats do we have in our sample? 46. And how many teachers do we have in our sample? 38. So that's your numerator. Simply the sample size of each of these two groups, Democrats and teachers, multiply those two and then divide it by your total sample size, in this case 100. So here's our work. 38 times 46, all of that divided by 100 equals 17.48. And notice that we denoted this as EC, as the expected count. And so the way we can interpret this expected count of 17.48 is simply, if occupation and political affiliation are independent of each other, then we would expect to see in a sample of 100 people, about 17.48 of those individuals to be and identify as Democratic teachers. So why don't you go ahead, pause the video, and work through these other 2 examples. Go ahead and try to find the expected counts of Republican salespeople and the expected count of independent farmers. When you've got your answers, go ahead and unpause this video. Alright, so let's see how you did. So let's first work with Republican salespeople. So how many Republicans are there? There are 38 Republicans. And how many salespeople are there? There are 32 salespeople. So 32 times 38 divided by our total sample size, which is 100, equals 12.16. So we would expect to see 12.16 people out of 100 people to identify as Republican salespeople. And what about the expected count for independent farmers? How many people would we expect to see in a sample of 100 people that would identify as independent farmers if occupation and political affiliation are independent of each other? 4.8. We have 30 farmers and we have 16 independents, so we would expect to see 4.8 people out of 100 to identify as independent farmers. So this is a first step to really calculating and getting your chi-square analysis. What would we expect to see if the null hypothesis is true? And this is all in relation to the population, because this is all about the null hypothesis. So in the population, we would expect to see this. And again, this is always in reference to how many people you have in your sample. In this case, we have 100 people. So once we've identified what our expected counts are for each of our cells and each of our events, we can then calculate what's called residuals. Well, residuals is simply the difference between our observed and our expected counts. So our observed counts is simply what it is that we actually see within our sample. We know that we had 26 people who identified as Democratic teachers, but we expected in a sample of 100 people to see only 17.48 people. So this difference of 8.52 people is called our residuals. And we can calculate the residuals for every single cell, where we see that among Republican teachers, we only had 10 people within our 100 identify as Republican teachers. But we expected in the population that if the null hypothesis is true, to only see 14.44 people within 100 people in our population. So we actually see a negative residual, a negative 4.44. So we actually see less Republican teachers in our sample than what we expect. And we see actually more Democratic teachers in our sample than what we would expect. So as you can see, we have all of our residuals calculated for each of our cells already. And I have highlighted in pink here the positive residuals compared to, in the bolded black, your negative residuals. And the reason I did this was just to highlight to you how sometimes we have positive and negative residuals. Well, here's a cool thing. If you were to calculate the sum of the residuals for each event, for each row, for each column, you would expect that to equal 0. So try it out. Calculate the sum of the residuals for all teachers. Calculate the sum of all the residuals for all Republicans. This should equal to 0. And this is another way that you can check whether or not you filled out your contingency table correctly. And we'll talk about residuals a little bit more when it comes to writing out our conclusions for step 5, because this is really what we're going to be using for us to be able to talk about where we may be finding significant differences. So now let's talk about actually calculating our chi-square test statistic. So here is your formula, where your chi-square test statistic is equal to the summation of your observed minus your expected squared divided by your expected counts. So essentially, it's your residual squared over your expected counts, and you add all of those up for every single event that you have, all of your cells, and that will give you your chi-square test statistic. And in general terms, if you have a high chi-square test statistic, a large number, then this is an indication that the pattern of differences among the groups on the DV exist. And since we have a pattern of differences among the groups on your DV in your IV, then essentially your two variables are related to each other, that they are not independent of each other, that really there is some relationship going on, that we end up seeing differences between groups within your IV on your DV. In this case, we would end up seeing differences between teachers, farmers, and salespeople on political party affiliation. That these two variables, occupation and political affiliation, are related. But if we have a low chi-square test statistic, then this is an indication that there are no patterns found within the groups of your IV on your DV. That these two variables are independent of each other, that there is no relationship. We're not going to see differences between farmers, teachers, and salespeople on political party affiliation, that there is going to be nothing going on there, that there really is no relationship between these two variables, thus they are independent events. So when it comes to calculating your chi-square test statistic, one of the nice things about this test is that you won't actually have to calculate this by hand. But one thing that I want you to know is actually how you do calculate it. So I'm just going to kind of show you quickly how it's done. Because for the most part, you will be going through most of the work. You're just going to be doing all the extra little work to actually calculate your test statistic. So here we see our cells along with our expected counts and the residuals. And really what we see in the header is this O minus E is simply your residuals observed minus your expected. And that gives you your 8.52 residuals for Democratic teachers, negative 4.08 residuals for independent teachers, and so on and so forth. When it comes to actually calculating your test statistic for chi-square, again, all you're doing is taking the residual, squaring it, and then dividing that by the expected count. So if we're looking at Democratic teachers, we have the residual of 8.52. We square that, then we divide it by the expected counts of Democratic teachers, which is 17.48. That gives us 4.1528. So if we were to do this for every single cell, and we add all of them up, then we get our actual chi-square test statistic, which in this case is 19.671. But again, you won't have to calculate your chi-square test statistic by hand. I will actually give this to you. I just want you to see how we actually go about calculating this, because everything you do in this contingency table is what you're going to have to do. But what you won't have to do and show me is everything to the right here, the actual calculations of getting your test statistic. I will actually give you your chi-square test statistic.